All right, so let's start with increasing, decreasing. Remember, use the x values. I think it even says in the directions here. So we read a graph like a book from left to right. So this is obviously the decreasing section. So it's decreasing. That leftmost x value is negative infinity. It stops decreasing at right here at this point, and that x coordinate is 1. And then, of course, from there, it is going uphill from left to right. So that is the increasing section. So it starts increasing from 1, and it does not stop increasing. So the rightmost x value is positive infinity. The vertex is just this lowest point. It's the minimum value in this case. So the vertex is the point 1, negative 4. In behavior, we got two ends to this graph, so we've got both. This is the right end because x is approaching positive infinity. It's getting bigger. So we look at the right arrow. Is it going up or down? It's going up. So that means y is approaching positive infinity. The left end, the left arrow. Left arrow is also going up. Number 13, it might be helpful to graph that one first. You can either graph it by hand or you can graph it using your calculator here. And you didn't have to graph it because you kind of know it should have been a flipped upside down graph. And the key point, the vertex will be right here at, should be 5, 0 because we shifted right 5. But it is helpful, especially for increasing, decreasing. So from left to right, we're coming from the left, and we stop increasing right there at that point. So the leftmost x value is negative infinity, since it's coming from the left forever. And then it stops increasing at that point right there, and that x coordinate is 5. And then from there, it starts to go down. So that next section is our decreasing section. Got to be careful here. It's decreasing from 5 to positive infinity. Yes, it's going down, but remember we're looking at the x values, and the x values, as we head this way, we're actually heading to the right. So we're going down and to the right there, so the x values are actually getting bigger. The vertex, we already said, should be at point positive 5, 0. And then lastly, in behavior, the right end, the right arrow is right there. It is going down, and so is the left arrow. So the end behavior is negative infinity for both. It's possible for end behaviors to be opposites. It all depends on which direction those arrows are going. Domain range. Remember, domain is the x's. It's how far left and right the graph goes. Range is the y's. It's basically the vertical distance that's covered. So this first one should have an arrow on the end and a dot there. So is this graph going left and right forever? And of course, it is not. I'm going to write my answers in interval notation. You can use set builder, but the answer key is going to be interval. So the leftmost x coordinate is right here. And that x coordinate is at -2. And then it is going right forever, though, from that point. So the domain goes from -2 to positive infinity. Remember, bracket around a number if there's a closed dot, parenthesis around an infinity symbol or an open dot. Range is how far up and down the graph goes. Again, it does not go down forever. It has a lowest y coordinate, and that y coordinate is 0. It's going right, but it's also going up forever. It's just going up a little more slowly than it is going up. So there's the range. This next one's kind of hard to see what that point is at, but I think that lowest y value is at -3. First question we got to ask ourselves, again, there should be arrows here. Is this graph going left and right forever? And it is. Of course, most people say it's going up forever, which is true, but it's going up and to the right. It is going up and to the left. So domain is all our numbers. Say that. If you want to have the words all real numbers, you don't have to have both. Range is how far up and down it goes. It is, of course, going up forever, but it does not go down forever. It has a lowest y coordinate. And again, we established that as -3. All right, here we got a couple tricky graphs. Notice we have an open dot. Remember what an open dot means. So first domain. Graph is definitely not going left and right forever. It has a leftmost point. It has a rightmost point. So that leftmost x value is at -3, and the rightmost x value is at +2. We'll put a bracket around 2 since it has a closed dot. We'll put a parenthesis around -3 since it has an open dot. Remember, that means it's not including that number. Range. Range is how far up and down it goes. Same thing. It is not going up and down forever. You got to be careful. This is the lowest actual dot on the graph, but the lowest point on the graph is really right there because it dips down below the x-axis. So that lowest y value is at -1. And then it has a highest y value. It looks like, let's see, 6. I'm going to put a bracket around 6 since it's a closed dot. I'm going to put a bracket around -1. If they don't tell you what kind of dot it is, assume it's a closed dot. Only time you'll use a parenthesis around a number, like we did here, is when you actually can see an open dot. All right, and this last one, domain. Left and right. Does this graph go left forever? So this arrow, we've got an arrow. This arrow is going down and also very slowly to the left forever. This function stops here. Then we've got another function in the same picture. So we're reading the domain of this entire picture all together. It basically starts where this one left off. So is that arrow going right forever? Yes. So the domain is all rows. So we're reading the domain of the entire graph all together. And then finally, range, how far up and down it goes. This one definitely goes down forever because in 2 different places, you've got arrows that are pointed down forever. So we know the range starts at -infinity. Question is, what's the highest y value? And it's right here. It's the highest the graph gets. We're looking at both graphs together. And that highest y value is at +3. And again, we've got an open dot, so we use a parenthesis around 3 instead of a bracket. Number 16, circle all of the following functions that have a range greater than or equal to -2. So basically in an interval notation, you're used to seeing it that way. That's the range we're looking for. So we're looking for anything that has a lowest point of -2. Well, this one, x + 2 is a line. Or lines, unless it's a horizontal line, they go up and down forever. So it can't be a line. So which other graphs up here have a lowest point of -2? Well, this one here has a -2 on the outside. So if you think about it, this vertex has been shifted down 2 units. And then same thing with this quadratic. -2 on the outside, it's going to shift it down 2 units. And it would be everything greater than -2. So that's why its range is greater than -2. It's not this one, because +2 on the inside just shifts it left 2, but it doesn't shift it down 2. So that one would have a range that's greater than 0. Same idea here. This is a horizontal shift, so it's not going to change the range. So just those two answers I've circled. Number 17, describe how the graph of f of x is transformed to get this graph. So really a lot of what we did on that first page. You got a 3 on the outside, so that stretches the graph. You got a positive 2 on the inside, that's a horizontal shift. And then number 18, use words to compare and contrast. So you want to explain what they have in common and what they don't have in common. Most people can tell those are different types of shifts, and that's what they don't have in common. But what they have in common is they're the same basic shape. They're both functions of f, so it's the same basic shape, these two graphs. So if one of them's a quadratic, then so is the other one. So they'd both be U-shaped graphs. They're both absolute value. They'd both be V-shaped graphs. So that's what they have in common. The differences are f of x minus 4 is, of course, a shift right 4 units. F of x minus 4 is a shift down 4 units. A lot of different correct answers on 19. You're sketching a function with a 0 at -3, a y-intercept of 0, 2, and it has an end behavior as x approaches infinity, y approaches negative infinity. So that means this is the right end. The right end is going to be going down forever. The rest of the graph can look however we like it to. You'll notice it uses the word include. The zeros include -3, so it could have multiple zeros, but it's at the very least got to have a 0 at -2 and a y-intercept. But the right end has to be going down. You technically don't even need a left end. I'm going to go and put one. There's a lot of different right answers on number 19. 20, graph a function that has a domain of less than 5 and a range of all real numbers. So a domain of less than or equal to 5 means it has to exist to the left of that red vertical line. Range all real numbers means it's going to be going up and down forever. So there's a lot of different right answers to this as well. Notice it's a V-shaped graph, but it's not really an absolute value graph. That is one correct answer. It's going up and down forever, but it is the left of +5. And then finally, inverses. It's where you swap out the x and the y. First step, rewrite it instead of f of x. Write it as y equals, and then swap out the x and the y, and then solve for y. And then rewrite the answer once you solve for y, rewrite it as f inverse of x. Use that symbol. Remember, you can also separate this as 1/2 x plus 3/2. That would be correct as well. If it's multiple choice, you need to know how to get both those answers. Remember, this one's still pretty much the same way, except toward the end. Instead of dividing both sides by 2/3, you do not want to do that. You will not get credit. You want to multiply by the reciprocal of 2/3. And that cancels out the right-hand side, and then you distribute the 3/2 there. So there's our answer to 24. And then there's the last couple answers. I skipped kind of the initial step there, but it's pretty basic algebra as you go through finding the inverse.